This is the problem 2. And we need to for this problem we need to find if each function can represent autocorrelation function and the spectral density function. And for the first of all, if R2 is a correlation function of a real WSS stochastic process xt, then it is even and R2 is less equal than 0. And its Fourier transform is non-negative. And if S omega is a power spectrum of WSS process xt, then it is non-negative. So now we can start to prove. For the first function is this, and it can represent an autocorrelation function because this function is even. We can easily know that it is even, and it like this. And we can know that for the 0, when tau is equal to 0, it is maximum. So we can easily get this. We can get this, and this is we transform the Fourier transform. We can know that the value is greater equal than 0, so it is non-negative. So we can prove it can represent an autocorrelation function, and because it is non-negative, so it also can represent a power spectrum. And for the question 2 of question B, the function is like this, and it also can represent an autocorrelation function because this function is even, and tau, when we can get tau it is close to 0, and the value is 1. 1 is maximum, so we can get that R tau is less equal than R0, and its Fourier transform is non-negative. And we can easily know that this is great. We can easily get this because this is non-negative. This is non-negative, so this is non-negative, so it can represent a power spectrum. And for the question C, this is function, but it cannot represent an autocorrelation function because it's non-negative for the Fourier transform. So, but is whatever the interval is, it always non-negative, so it can represent a power spectrum.